Okay, so this is the second of two videos for tonight. For problem number 4, using words for an expression, actually we're going to look at some expressions and see if we can figure out how to use words to describe those expressions. Okay, so for the first one, we're trying to describe this situation right here, and we have x and then another number 8.1 with a plus sign in between. So the words that we use to describe that situation are right here with the exception of that little question mark right there, and that's what we're trying to figure out right there. The blank of a number x and 8.1. So using those same words that describe the operations, we can see that we have a plus sign here, and the word that represents adding that would fit right here, the blank, you wouldn't say the adding of a number x and 8.1, you'd say the sum of a number x and 8.1. I think I might have just said 81, I'm not sure. For this next one, we can see, if you look at the expression first before you look at what the words are, you have the sum of something, okay? The sum of a number 9 and something else, and that something else we'll talk about in a second. But the sum of, so we have the sum of something, okay? And then we have 10 and the x right next to one another, and 10 and an x right next to one another mean that it's 10 times. These two numbers are being multiplied. We have a 10, a number, being multiplied by x, a variable. So 10 times x. So the sum of 10 times a number x, so that would be the second word that goes there, and then and 9. So 10 times the number x, if you remember PEMDAS, we do the multiplication here before we do the addition. Okay, so we have the sum of 10 times the number x and 9. The next one, we can see we have a quotient, okay, of n and 3. Okay, so 3 is down here. The quotient, and the first word, or the numerator is always the one that comes first. Okay, the quotient of the numerator and the denominator. Okay, so we have the quotient of n and 3, or you could say a number n. Okay, probably should say that, a number n. Okay, and then for the last one, we have the difference. Okay, what does that say right there? Is that an I? 1 less, oh, 1, that's a 1. Okay, so that was an interesting way to say that. 1 and then something minus something else, that would be 1 less than. Okay, so that right there would be a 1 less than the product of 5 and a number x. So we'll say 5 and x. Okay, so 1 less than the product of 5 and x. Okay, so that's that one. Down here at the bottom, we can see we have an application kind of a problem. Can we use what we're learning to actually describe something that actually happens? You'll see this in geometry. You've got this hexagon. It's a regular hexagon. It doesn't even matter if it's a regular hexagon. It's a hexagon. But this is a regular one. And then what we're seeing here is that we have a segment drawn from any one vertex. So the corners where two sides meet, those are called vertices, or one part here where one side meets another side, that's called a vertex. So from any one vertex, it says, you can draw a segment to another vertex. And so in a regular hexagon, how many could you actually draw from a vertex to the other side? So it says, a sample for a regular hexagon is shown at the right. Use the table to find a pattern. What is the rule for the number of non-overlapping triangles formed? Okay, so when you draw a line segment from any one vertex to all the other vertices, okay, here we drew 3 of them. How many triangles do you see formed? Well, if you count the triangles, we have, I should get a different color. If you can give me just a quick timeout, good to get a different color here. Okay, so we can see we have one triangle here, then we have another triangle here, That's the second one. Then we have a third one right there, and then we have a fourth one. So we can clearly see that we have 4 triangles. Okay. Well, a polygon with 4 sides, a polygon with 5 sides. All right, maybe this is going to continue on the next page. I don't know. But notice if we have 4 sides, and if we draw a segment from one vertex to another, we just formed 2 triangles. So the number of triangles would be 4 sides minus 2. So that's equal to 2. So a polygon with 4 sides, we get 2 triangles. A polygon with 5 sides, if you actually drew it, you have 1, 2. You can do this on your own too. 1, 2, 3. We have 3. So 5 sides minus 2. It seems to be a pattern here. Remember, with 6 sides, we had 4 triangles. And then, okay, so a polygon with 5 sides, we've got 3. But what would this guy be right here? Okay, the number of triangles for n, okay, notice that 4 triangles, sorry, 4 sides, and then you subtract 2 from that number to get the number of triangles. If we have a 5-sided figure, you subtract 2 from that number to get the number of triangles. Same with the 6, and then that would mean that same with the n. If n represents an unknown number of sides, we know that n minus 2 would be the number of triangles formed. You might be thinking, what in the world are you talking about? Well, let's just say that n is 100. We don't want to draw a 100-sided figure. If n were 100, then how many triangles would be formed if the polygon had 100 sides? Well, if the polygon had 100 sides, we could sit there and do that. 1, 2, 3, 4, 5, 6, 7. That would be like almost impossible to draw a decent-looking polygon that has 100 sides. But we can use the pattern to figure out how many triangles. So I want you to pause the video and see if you can figure out, if I had a 100-sided figure, how many triangles would be formed. Well, time in, it would be 100 minus 2, because the pattern doesn't change. That's why math is beautiful. Patterns don't change. So 98 triangles. Okay. Now, I realize that's not necessarily going to be something that changes your life or anything, but nevertheless, finding patterns in mathematics is a big deal. So this is good to be able to see patterns. There's patterns all over the place. And I don't want to overwhelm you with how many times you're going to see patterns, but that's a big deal in math. Okay. So last page. Okay, underline the correct word or words to complete the sentence. The value of the expression in the table for a 6-sided figure is not the same as the number of triangles in the drawing of the hexagon. Is the same. Okay, give a rule to find the number of overlapping triangles in a polygon. We already talked about that. That's n minus 2. An algebraic expression. Oh, in words. That's not words. I don't like doing words. Give a rule in words. The number of, okay, I will do it anyway. The number of triangles is the same as, is always, I should say, always 2 less than the number of sides. Okay, so I went right to the notation instead of the words. That's why I chose math. I don't like to write a lot of words, but Common Core, got to write a lot of words describing what you know. Okay, that's what it means. The number of triangles is always 2 less than the number of sides. And then we write down here, that's what they want, n minus 2. Okay, now, lesson check. Do you understand? And math success are the 2 sections that I want you to cover and do these before you come into class on Monday. So pause the video, do the lesson check, okay, and then do the math success part. This is just you giving me some feedback, and bring this into class on, like I said, on Monday. Okay, pause the video, and then you can play the video. I'm still going to show you how to do it, but pause the video to see if you can do it on your own. Okay, so here we go. reasoning, use the table to decide whether this or this represents the total cost to rent a truck you drive in N miles. Okay, just to let you know, most of the time when you read a word problem in math, it doesn't make sense right away. Okay, you've got to dig a little deeper, and you have to do a little work to figure out what is being talked about. Okay, so write a rule in words for the pattern shown in the table. Let's just look at the table and see if we can figure this out. The number of miles. Okay, so basically you've got the total cost to rent a truck that you drive N miles. This is a totally common thing. I was in Minnesota this summer, and I rented a car, and there's a cost involved in renting the car. Okay, there's an initial cost, and then there's a cost per mile. Okay, so that's the way it goes. An initial cost plus a cost per mile. Write a rule in words for the pattern shown in the table. If you drive the truck here 1 mile, then it costs $49 plus 75 cents times 1. Okay, so the key things to look for in these are, if the number of miles is right here 1, then where do you find a 1 over here? All right, there's a 1 there. 2 miles, we're going to take 2 and multiply it by 75 cents. 3 miles, it's still 49 and the 2. It's 49 plus 2 times 75 cents. Excuse me. If you drive the truck 3 miles, then you can see it's still $49. That's a flat fee plus 3 miles times 75 cents. Okay? And so if we want to, we can just fill in the pattern here. Just keep writing what stays the same. So the $49 stays the same, plus, and then 75 cents stays the same. I don't need to write that the dollar sign. Times, I don't like that X either. Times, but we're going to keep it consistent. And then N, see it's 1, 1, 2, 2, 3, 3, N, N. Okay, so write a rule for the pattern. Well, the rule would be the cost, total cost, is $49 plus, I'll use a symbol there, plus 75 cents times the number of miles driven. Okay, so that's what we're talking about here. All right, so that's how much it costs to rent the truck. A flat fee of $49 plus 75 cents a mile. Okay, now write an expression for that. And the expression for that is exactly what we have here. 49 plus 0.75 times N. There's our expression. Okay? All right, well, there you go. And then math success, check off the vocabulary words that you understand. This is totally you. I can't show you what to write here. If you understand what variable means, then you'd be able to say something like, a variable is just a letter that represents a number. A variable is just a letter that represents a number. Okay. If you look back at your original page 1, it says the variable is a symbol, usually a letter, that represents one or more values of a quantity that changes. Okay. Well, I like this to say a variable is just a letter that we use to represent a number. Okay, that's it. A variable is used to represent a number. An algebraic expression is an expression that has one or more variables in it. Okay, that's what an algebraic expression is. So you should be able to explain that. So if you check this box, that means that I could ask you the question, what is an algebraic expression? You would say an expression that has at least one variable in it. If I said, what's a variable? You'd say a variable is a letter that's used to describe a number, or that's used to represent a number. So it's kind of like it's a placeholder. That's all it is. A variable is a placeholder. We're not sure what the number is, or it's a number that can change. Okay? And then a numerical expression would be if you understand that, you'd be able to say a numerical expression is an expression, a phrase that has that in, I'm just trying to read it at the same time. I'm trying to give you the same wording that the sorry. Oh, I'm over my 15 minutes. Darn it. A phrase involving numbers and operation symbols but no variables. All I was going to say is a numerical expression is an expression that contains no variables. Okay? And then how well can you write algebraic expressions? Give me a reading here on from 0 to 10. 10 would be now I get it. Need to review. Somewhere along here, give me a maybe it's somewhere like 9.1 or something like that. So you'll put a star or a circle like that. Okay, and that's it. That's all you have to do. And then bring these papers to class on Monday for full credit for your homework.